So if we talk about the progression from equations to vectors to matrices to data, this progression describes the transition from manual logic to automated intelligence. So we are talking about the transition from manual logic. So equations, they are valid only if the only for static systems. So equation is like a manual logic. So we are transitioning from manual logic to automated intelligence. See, as the number of variable grows, we stop focusing on the answer and start focusing on the system. So classical mathematics, it was all about identifying the single unknown or analyzing the single unknown. So in classical algebra, the focus is on isolation. You have one scale, one balance, and one missing weight. So in classical mathematics, in classical algebra, what we used to do is we used to solve, like we used to perform step by step arithmetic to isolate x and get the value of x. Now the scope is very limited. The scope is like small scale, human solvable problems. Like we can solve problems like if I have $10 and apple cost $2, how many apples can I buy? So such problems can be solved using classical algebra, using equations. Now the limitation is it cannot handle complexity. If you have 50 variables affecting a single outcome, writing 50 separate equations is inefficient and brittle. So if we talk about the classical mathematics mindset, the idea, the philosophy is to find the value. But if we talk about linear algebra, in linear algebra, we are dealing with the interconnected systems. We are dealing with set of simultaneous equations. We are not just talking about one equation, we are talking about simultaneous equations. So linear algebra moves from one at a time to simultaneous logic. It recognizes that variables rarely act in isolation. They influence each other. So linear algebra is all about analyzing the simultaneous logic and interdependence between the variables. So if we talk about the workflow, so in linear algebra, you pack all your variables into a vector X and all their relationships into a matrix A. So we have a matrix and a vector. Vector is the variable and the matrix contains the relationship between those variables. So as you can see here, on the right side of the equation, we have a vector which is representing a variable, like set of variables, and on the left side we have a matrix which is the holding the relationship between the variables. So these numbers are like the weights or numerical measure of the relationship between the variables. So innovation, what is the innovation in linear algebra? So instead of solving for a single unknown x line by line, we use matrix inversion or decomposition, like the Gaussian elimination, to solve the entire system in one mathematical stroke. So we solve the entire system in one mathematical stroke. And what is the scope of linear algebra? It has a role to play in engineering, basic physics, economics. Like we can answer questions like how do these 10 ingredients interact to create this specific chemical yield? So when we are talking about how the variables are influencing each other, we are talking about linear algebra. In linear algebra, we are analyzing the interconnected systems. So in the transition from manual logic to automated intelligence, we have machine learning, which is the massive scale. So machine learning is essentially linear algebra at scale, or you can call it linear algebra on steroids. Like while a structural engineer might solve for 100 variables, an AI model like GPT-4 solves for trillions of parameters. So here we are talking about linear algebra on steroids, linear algebra at scale. We are not talking about 100 parameters. We are talking about trillions of parameters. So now let us try to understand the workflow of machine learning. So here you don't have a single result. Rather, you have a massive data set of bees. The goal is not just to solve the equation, but to find the best fit matrix A for the massive data set of bees. So once again, see, the idea is that we will consider this equation. Now B, we know that B represents the variables. So in machine learning, this B will be massive. We will be having a massive data set of variables, and this A is unknown. In machine learning problems, this A is not known to us. This A is unknown. So the idea is to find this A, find the relationship between the variables. That is what the machine learning problem is. So for machine learning is finding the best fit matrix A for the massive data sets of B's. Because this A is the relationship matrix. So machine learning is all about finding the relationship matrix for the massive data sets. Now, what innovation we have in machine learning? Optimization via gradient descent. So since the system is too large for a human to write the equations, we use optimization, we use gradient descent. So the computer guesses the weights in the matrix, checks the error, uses linear algebra to nudge those billions of numbers until the error disappears. So that is what the automated intelligence is. So system on its own, it will learn the relationship. The system on its own will learn the relationship. And that is what machine learning is. Machine learning is made up of two words, machine and learning. Here, machine is the computer, or you can call it algorithms. And learning means they will learn. What they will learn? They will learn the matrix, relationship matrix. They will learn the relationship matrix. They will learn the relationship between the variables. So algorithms will learn the relationship between the variables on their own. That is what the automated intelligence is. So they will make use of some mathematical techniques like optimization via gradient descent, where they will start with some guess, some random guess, and they will calculate the errors and fine tune the parameters to minimize the error. That is the core main idea of machine learning. Now, what is the scope of it? Scope of machine learning. So it is the modern magic. Like based on these billions of pixels, what is the probability that this is a picture of a cat? So with machine learning, we can very easily do image recognition, we can do classification, we can do some sort of forecasting, some sort of predictions. So that's the scope of machine learning. So we saw the shift in philosophy. Like initially, we were interested in finding the value in the classical algebra. But in the linear algebra, we started finding the intersection, the relationships. And in machine learning, the philosophy is to find the patterns, to find the relationship matrix, to find the patterns. So by moving from equation like 2x plus 3 is equals to 7 to an equation like ax is equals to b at scale, we have moved from calculating results to simulating intelligence. So in the modern world, the linear algebra is about simulating the intelligence, wherein we are dealing with equations like ax is equals to b, wherein b is a massive data set and a is a massive relationship matrix, which we are finding, which the machine learning algorithms they are learning, they are finding using some sort of optimization techniques like the gradient descent. And that is what automated intelligence is about. That is what simulating intelligence is about.